So everybody close your comments real quick. We're going to go over the next assignment and get ready for that. So just so you know, the next assignment, or the assignment from yesterday is still open. If you did not get a chance to finish it, it's up there ready to go for you. This. So yes, Charles's Law is still open through the end of the day today. I opened up Avogadro's Law today. It will be open through tomorrow. And so we're going to work on this for 2 days just to give everybody a chance to get caught up. And like I've said before, you may, like at any point in time, this might just click. If you haven't gotten it yet, we're getting in enough practice where you might be getting more comfortable doing the cross multiplying, plugging in the numbers, changing the temperature. And so if you want to go back and finish up any of the other ones, Boyle's Law, Gay-Lussac's Law, Charles' Law, just let me know. I'll open them up for you, and you can work on them, up to a certain point. At a certain point, we got to move on and keep going. But if you want these open back up, just let me know, and I will get them open for you. But today, we're going to move on with Avogadro's Law. This does concern moles because it's Avogadro's Law. The good news is you do not use Avogadro's number. You're not going to be converting from grams to moles, at least not yet. Maybe later they might throw that in, but on this assignment, I don't see it. And so you're just using moles as a unit, just like we've been using temperature and volume and pressure. And so here with Avogadro's Law, it states that the number of moles of a volume of gas are directly proportional with temperature. The moles and the volume of a gas are directly proportional. So remember that directly proportional means they go up and down together. And just think of this as like a balloon. If I were to untie the knot on this balloon and put more air into it, like I literally blow more air into it, what I'm doing is changing the number of moles. I'm putting literally more air into the balloon, so there's more molecules in the balloon, more moles. What's going to happen to the volume if I blow more air into the balloon? What's the size of the balloon going to do? It's going to get bigger. So the more moles I put in, the more volume I have. Those are going to go up and down together. As the moles go up, the volume should go up. As the moles go down, the volume should go down. So just remember that's a direct relationship. When a greater amount of gas is present, you need more volume to occupy that gas. If I have less gas, I have less volume. So their example here, let's see if this plays the video. It didn't play the video. They're just going to open up this valve from the tank, put more air into the balloon, and as they do that, the balloon's going to expand in size because I just have more air to fill up that area. And the pressure's staying the same here. So just remember that your pressure and your temperature don't change. So here's our formula. V1 over N1 equals V2 over N2. I've got it written on that board over here, and I have it written on this board over here. They're going to give you 3 of these numbers, and they're going to leave one off, and you just need to cross multiply and solve for the one that you don't have. So let's go through the examples. How many moles of carbon dioxide gas are present in a 9.6 liter sample? So they've already given me a volume here, and I'm going to guess this is my first volume. So how many moles of carbon dioxide gas are present in that volume sample if 4.2 moles was contained in a 5 liter sample? So I'm guessing these two go together. The 4.2 moles and the 5.0 liters is my volume 1 and my volume 2 and my moles 2. And then the 9.6 liters is probably my volume 1. So I'm just going to plug those in over here. Let me turn my video around. And I don't need to convert anything for this. So my volume 1 is 9.6 liters. I don't know my moles 1. That's what they're asking me for. And then my volume 2 is 5.0 liters. My moles 2 is 4.2 moles. And now I just need to cross multiply. So what I'm going to multiply is the 9.6 and the 4.2. So 9.6 times 4.2 is equal to, the other two multiplied together, 5.0x. And so now for this one, I just want to get the x by itself. That's what I'm trying to solve for. I'm going to divide by 5.0 on both sides. And so now, once I've divided by 5.0 on both sides, I can see that I'm multiplying my 9.6 and my 4.2 together, and then I'm dividing by that 5.0. And so if we watch what sapling does, we will see that they do the same thing here. They're going to plug their numbers in, do the cross multiplication. They get the same setup that we have, and they find out the answer is 8.1 moles. And that makes sense because my volume goes down. So I'm going from 9.6 to 5.0. So I expect my moles to go down. It goes from 8.1 as my answer at moles 1 to 4.2 my answer for moles 2. So it did go down as well. So they go up and down together. And then they just do one more example. This one, they're just solving for this. Let's go ahead. Let's do this, and then I'll show you the one thing that is a trick that they do on this assignment that you need to be able to know how to do. So this one's just going to be the same. We're going to plug this in to our formula. We can use milliliters. That's fine, as long as they want milliliters as an answer, or as long as both my volumes are the same. So a balloon with a volume of 575 milliliters contains 0.024 moles of oxygen gas. That's my volume 1 and my moles 1. So I have 575 milliliters and 0.024 moles. And then it tells me if 0.05 moles of oxygen gas is added to the balloon. Okay, here's a key. This is something they're going to start to do maybe halfway through the assignment. Added to the balloon means that is not my second moles. That's how much I added to the balloon to get my second moles. So imagine I have 0.024 moles in the balloon already. Then I add some more by blowing into it. I need to add those numbers together to get my second mole. So I need to add the 0.024 and the 0.05 together. That will be my second moles. So my second mole should be 0.074. Because 0.024 plus 0.05 is 0.074. So that's my second moles. And then I'm solving for x, my second volume. That's what they want from me. So again, I'm going to cross multiply. I'm going to multiply these together. 575 times 0.074 is equal to, turn this around here so we can see. It is equal to, the other two multiplied together, 0.024 times x. I want to get the x by itself, so I need to divide by the 0.024 on both sides. And when I do that, this cancels out, and all I'm left with is x. And so I'm multiplying these two numbers together, dividing by the 0.024, and that should give me my answer in milliliters. Which we'll go ahead and see. And yes, they did exactly like I did. 575 times the 0.074 is equal to the 0.24. And you can see right here is where they had to add their moles together. So they had the 0.024 moles at first, then they added 0.5 more. So their moles number 2 is 0.074, just like we got. The only thing I will show you real quick, let me pull this up. On some of the sapling questions towards the end, let me go ahead and click on it. Rocco's Law, preview. Okay, so like starting at number 10, what they do here is they give you, so this is a pretty straightforward problem, but they give you two different volumes in two different units. So I have 575 milliliters, which milliliters is pretty small, versus 3.87 liters. Those are two different units, and they got to be converted to the same unit before you do any of your math. That's the only thing. So over here, to convert volume, I would just do it from milliliters to liters. That'll be a little bit easier. You don't have to worry about both ways. You want to go from milliliters to liters, move the decimal 3 times to the left. So 500 milliliters is equal to 0.5 liters because I moved that decimal 3 times to the left. If you do that, that's how you convert from milliliters to liters. And so on here, when I set up my problem, I would use 0.575 and 3.87 together. Because when I convert the milliliters to liters, I move the decimal 3 times, and then it goes in front of the 5 to be 0.575. So if you do that, that should get you to the correct answer. Go ahead and work on it. If you have any questions, let me know. If you want me to work a problem, I won't come by your desk, but you can just tell me what problem you have. I'll pull it up on the board, and I'll do it over here on the board with you. So if you have any questions, just let me know, and we'll work through it. Or if you'd rather not like do it in front of the whole class, just send me a screenshot in the email of your problem, and I'll be able to help you out through the email. Nice. Everybody have a nice day.